I would quickly like to check from the audience if we are visible. Can you hear us? So you can post in the chat, please. Can you hear us? Oh, great, great, great. So we can start now. So hi everyone, I'm Shravani. First of all, thank you so much for taking out the time to attend Crypto Innovation Webinar Interview Series. I welcome you all. The series is all about cryptography and the magical innovation in the field of cryptography by the Indian startups and the researchers. Today is the part 3 and the topic is Cryptographic Identity, the keystone of modern digital transformation, indigenous hyperscale cryptographic identity and the electronic signature technology. As a result of digital transformation, there is a phenomenal growth in the digital assets of the enterprise. The enterprise boundaries are fast fading, and hence it becomes daunting task for security teams to put barbed fence across the asset spread. The pace of the digital transformation has accelerated during pandemic. Digital transformation result into increasing IT assets, digital assets, and the attack surface area. And with the rising numbers everywhere, it's statistically proven that the number of attacks and compromises will increase unless enterprise can guarantee who can come in and who can do what. So what is interesting to note here is the definition of who in the digital world. In the current system, the entity accessing service digital assets could be person, application, and nowadays it's a thing. The current mechanism to define the entities are being the way of static identifiers. I stated correctly. We will see that in detail. Defined for the context, persons are identified by user IDs, customer IDs, device by IP address, device address, application in APIs by APIs IDs and URLs. The problem with these identifiers is identifier can spoof and central record keeping is most of the time not available, resulting into visibility loss and loss of control. Increasing number of assets in the system amplifies this problem exponentially. So can we resolve this problem? What is necessity in the today's digital world? Can we think of having unique but dynamic digital identity? And most important, is it possible to have homegrown technology to become Atmanirbhar Bharat? So let's find out all this from our guests today. So we have two guests, Mr. Nilesh Dhande and Mr. Shrirang Bapat. Welcome. So the little introduction about them. Yeah, hello. Mr. Shrirang Bapat, partner FortyTwo Labs. Shrirang is a part of a team creating innovative products in the field of cybersecurity, data analytics, DevOps to make an impact in defense, internet, and telecom industry. A FortyTwo Lab, Shrirang is responsible for product strategy of iControl platform, a new indigenously developed patent pending multi-party digital signature technology that does not require central public key infrastructure. Prior to FortyTwo, he has played various technology leadership role in the industry, most recently as the CTO of Sterlite Software and prior to the head of product R&D at MDocs and India and Pubmatic. He was part of TCS for many years and contributed to international growth of TCS in technology R&D services. Welcome, Shrirang.
Thank you.
So a little bit about Mr. Nilesh Dhande is partner FortyTwo Labs. Nilesh is seasoned entrepreneur, a high-tech executive with a track record of corporate innovation and deep experience in cybersecurity, internet, and mobile. Previous to FortyTwo Lab, Nilesh has been a co-founder in cybersecurity company, is a director of several companies, and has been technologist throughout with 20 years plus years in industry and a proven record of building and scaling innovative startups with the right balance of management and technical operation skills. Nilesh specialized in strategy building for taking new products to market and in making various new technology product initiatives financially viable and profitable. He has worked at various leadership positions across startups and large enterprises, like overseeing customer engagement, product management, and product strategy and sales. So I welcome you both in Crypto Innovation series.
Thank you so much,
Thank you
Ravani.
so much.
Appreciate it. I mean, we are very glad to be here. Thank you.
Okay, so audience, before going into deep conversation with Mr. Nilesh and Shrirang, I would like you to take a poll. I'm going to post few questions, like 3 questions will be there. I will allot 30 seconds for each questions. I request you to please vote. So I'm launching the poll. I hope you can see the poll. Can you please quickly answer? I mean, great. I'm going to close it. So let's see the results. Wow. So these are the results. What is your identity in the digital world? 30% has said phone numbers, 2 Facebook or Twitter ID. Then okay, 39 they said Gmail. Aadhaar is 22 and PAN. Wow, nice. Thank you so much. So I'm going to launch the second poll. Okay. So 30 seconds starts now. So I'm closing the poll. Let's see the results. What are the key challenges in digital transformation? Management confusion 4%, people unwillingness 6%, all above 64. Wow, that's nice. So we'll go for the next one. Okay. I'm launching the poll. 256-bit ECC is equivalent to access-bit RSA. Wow. This is for the crypto community, I guess. Okay, I'm closing the poll. Let's see the results. So 128, 11%, 3072, and 1024, 38%. Good. So, okay, so we got some polls, and now I think we can start with our conversation, Nilesh and Shrirang. So
Sure.
can you please tell me what is the fundamental problem or the challenges in the digital transformation? So what do you think?
Yes. So I think we looked at the polls just now, and we talked about the identity of the people, which said that half of the people had phone numbers, the other half had email IDs, but very few people were using Twitter ID, Facebook ID, and such kind of identities that are there on the internet. Fundamentally, we are now accessing more digital services for more people and on lot many more devices. And I think when people ask about the fundamental challenge of digital transformation, this is the challenge. It gets multiplied. It is more services multiplied by people, multiplied by devices. That's the important part. Not only that, with all these things, what happens is the attack surfaces for the attackers just increase in the same level. Not only that, people who have to access the services, my expectation is I can start a transaction on the phone and complete it on my TV, and in between I want to bring it on the laptop. Imagine the same transaction flowing across all these things. The security architecture becomes really, really complex. Now,
Correct.
how do I ensure that some part of my technology is coming from my hosted devices, some is coming from my cloud devices, some is coming from my edge devices? So the identity, the service, everything is spread everywhere. And that makes this whole issue of trust and cybersecurity very, very, very complex. On one side, it makes it complex. That means that people are unable to use the systems. If I start to make it easy, it becomes very easy for the attackers also to start attacking. So finding the right balance, is the number one challenge that I believe that exists in today's world to provide these many services to these many people.
Okay, you're correctly said. So do you think, like, nowadays AI, that is artificial intelligence and machine learning in cybersecurity, is being talked about a lot? So do you think that will help?
So obviously there is two parts to it, right? The same types of tools are available for hackers, and the same types of tools are available for protectors. As far as the hackers are concerned, the issue of convenience is not there because they are well trained. For them, the cost is an important factor. And when I say cost is an important factor, the way they are able to manage the sophisticated tools in low, and more low cost makes it difficult for the enterprises to access. That's one part of the story. AI, ML tools, etc., actually help you to diagnose, to prevent. Are they going to help you with the prevention? That's the big question. So cybersecurity does not mean that I'm going to do only defensive or only offensive. We have to find the right combination of protecting the assets before the event happens, as well as ensuring that after the event happens, I'm able to diagnose and I'm able to figure out the actual person who's going out and hitting my infrastructure, who's going out and hitting my transactions. So that is the fundamental challenge. AI/ML may not start that. The main challenge is that today, the internet we are using for all the access, internet was defined and designed for anonymous access. We are using the internet mainly for people to do enterprise access, and that's where the identity needs comes into the picture. So how do I take the internet that was designed for anonymous access, inside out, I turn it around and make sure that I have the identity of the people who are accessing available on the internet for the enterprise. The AI/ML approach is going to help me with the blacklist, whitelist mechanism. I can identify these guys are actually threat people, these IP addresses are good, but it's important for me to have a mechanism by which I have got appropriate defensive shields that no matter how much sophistication the hacker has on the internet, I am able to identify the identity of the people to whom I'm giving the service, identity of the services or application that they are using, identity of the devices from where they're accessing these. So many identities actually creates a massive challenge for all of us on the internet. And these challenges,
Yeah. So can we tell me problems and the challenge in the digital identity? I think that's what you were discussing about it.
Yes. So when I talk about digital identity, I mean, if you look at in the digital world, on physically, I am present through the video, and people who know me can identify me as a person that they have been working with. People who have been speaking with me can identify the nuances of my voice, the way I speak, the way the pauses I take, etc., the tone of my speech, etc. Now, in the digital world, when I'm doing a banking transaction, all these things are completely missing. So the problem in the digital identity is that I cannot trust it effectively because I have no means and mechanisms which I have in the physical world, just like I explained, my voice, my features, my face, my the way I'm moving my hands. So all these features are available in the physical world. In the digital world, if I'm doing a funds transfer transaction, none of these things are available. So that is where the trust becomes the number one problem in the digital world. How do I trust whether the person doing the transaction is actually what they claim to be? The second big issue in the digital world is usability. Most of us use what is called as the digital signature or the PKI dongle that I purchase. But I'm sure more than 80% of the people on the call will believe they would have their dongle with their CA. It's not with them. It's actually their personal property. But the dongle resides with the CA. And then why does it reside there? Because it's not usable. The usability is such a big challenge. And there's somebody makes a phone call, sir, OTP आएगा, आप मुझे बताइए. Now, this usability of secure systems makes it difficult for common people to use it. So we want to be on a mission to solve the problem of this usability, because the more usable the security is, it will be adopted by the people. But the general myth is that if I make it usable, it is less secure. And that's the balancing act that needs to be done to ensure that we are able to provide trust that is usable. And then the third big issue is interoperability. Aadhaar ID doesn't work here, Gmail ID doesn't work there. I have to have the number of IDs that exist for me in the digital world today, and the passwords I have to remember, and all these challenges makes it confusing, right? So these are like some fundamental challenges that are there that exist in the digital world for the digital identity on its own. So, and that's the problem that we took in our heads. So how do I make it simple? Why is it so simple for me to recognize a person when I know somebody introduces me? I've got my own physical mechanisms. How can I bring the easiness of natural identity into the digital world? That is, I think, something that we have to work upon.
Correct, you correctly said. I mean, like we have lot of identifiers, and that's what we are using, and we have to, they have different passwords, and we have to remember those passwords. So we have to create another file for it, and we have to again lock it. So it's the complex process, to handle so many identities. So yeah,
Exactly.
you are correctly said. So what do you mean by identity model? And why do we need the identity model? So can
So
Nilesh
yeah,
answer on this?
yeah. So thank you, Shravani. I think it is very interesting to actually look at the way identity is defined, right? And this is the way the identity is defined by the traditional. So this is the source which is taken from a Wikipedia, right? So which
Okay.
basically says what is an identity. Identity is basically an identifier by which you can actually operate into a digital world. And the standard definition, as per the standard ISO, it says it is actually a collection of an attribute. Now, there is a very important distinction, right, between the way identity is perceived, okay, and the way the identity is implemented. Okay, so there are two separate things, and many a times what happens is these two things are actually confused by most of the enterprises which are out there. Okay, so first of all, I think we all agree that we actually need a very solid identity model into a digital ecosystem, right? And when I say a digital ecosystem, as you have rightly said, digital ecosystem right now is composed of multitude of things, right? It is just not limited to humans. So identity are always is thought in the context of the humans, right? However, if you want to instill a trust inside any ecosystem, the identity has to be doled out to not only humans but all the participants of the ecosystem that is there.
Correct,
Okay,
correct.
and the participants are who? Participants are humans. Participants are apps and services, digital services, right?
Correct.
Those things are also interact with you.
We cannot ignore
There
them.
are
You are right.
absolute, and with this advent of IoT, there are billions of devices which will be there onto internet who will be
Correct.
communicating with each other. Those things also will need an identity. And of course there are enterprises which are like a legally defined person, as we call it, right? So the identity model has to be all encompassing model, right, which is able to give identity to everybody and everything. right? And now let's look at how the identity is perceived into the digital world. Okay, I think many of the people in the audience also will be able to relate to the slide that I'm showing, and they would say that yes, this is the way the identity is right now. But there is a very interesting differentiation between the way identity is defined and the way identity is delivered. Okay, all these models that you are looking at is the way identity is delivered and consumed. So you have a centralized identity model, right, which is primarily targeted towards an enterprise's internal ecosystem, right? Then you have external authentication models, maybe used by some governments and stuff like that, for basically addressing the onboarding a lot of partners who kind of use different kind of identity providers, right? PAN is authorized by somebody, GST is authorized by somebody, right? And all other kind of things, right? Then there are, so people have addressed in the poll that my identity is Google. Why do they say that? Because Google is now becoming a de facto for being an identity provider. Okay, whether that it is providing an identity or not, that is again an interesting question that we will discuss about that. Okay, then there are,
so it is actually surprising that they have gone with the Gmails and Aadhaar and all. So I think we got more. So it's surprising. Yeah, please continue.
The poll was very interesting actually. It was designed like that because we have not put any all of the above option there, right? So people were forced to choose, saying, okay, this is my identity into a digital world, right? So that is third model, which is as we call as a federated identity model. Federated identity model, you can expand the scope by saying there could be multiple enterprises and multiple identity providers, and then you can operate within that. And then now there is a movement towards what is called as a distributed identity model as well, with the advent of blockchain-based identity models which are out there. Now, what we have to understand is these are not identity models. This is the way the identity is provisioned. This is the way the identity is delivered, and this is the way the identity is consumed. Okay, what we need is basically, if you need to address all of the challenges that Shrirang has said regarding the provability, trust, security, and all that, is actually believe that we need a cryptographic identity model to actually instill the trust within the ecosystem. Okay, and that is the way I would say a fundamental rethinking is done in the way the identity is imagined in that form. Okay, because the true definition of an identity is also an interesting way to look at it. Okay, so just to summarize that, we have two things. What we have an identity definition itself, how you define the identity. Maybe the centralized identity model also can deliver the identity that we are talking about. Maybe the distributed also can be delivered. So the way the identity is delivered and the way the identity is, there is a differentiation inside that. And we firmly believe that unless identity is backed by the cryptography, provability cannot be instilled, right? And that is the basis what we are coming out to and what we'll be discussing subsequently.
So why do you say that the digital transformation and the secure cyber world, a cryptography identity is must? Why you are
yeah. So beautiful question. What I'll do is I'll break this question into two parts. Okay. I would say both are actually complementary to each other, right? Cryptography without an identity and identity without a cryptography. Just think about it. So let's say, I think last week itself, we had a webinar on quantum computing and quantum cryptography, right? So imagine now, so what I'm going to address first is why identity is needed for cryptography. And then I'm going to address why cryptography is needed for an identity. Okay. So nowadays there are basically advancement into algorithms which are coming out, right? People say that we have designed most secure algorithm. We have a quantum proof algorithm, right? But what does it mean? If you do not back it up with an identity, if you are able to generate those keys of those algorithms, that is the vulnerability point. Okay. Second paradigm, think about it. Then this is a very important paradigm. On internet, the possession of the key, okay, proves the possession of the home. So if you imagine internet as a home and the digital assets inside the internet as your home, if you possess the key for my home or my digital asset, you actually become the owner, right? So how does the probability come into the picture? So unless there is a backing of a cryptographic identity and I'm able to prove that the identity is in the possession of, or the keys are in the possession of that particular identity, cryptography won't make any sense. And people will actually vouch me for that, right? And that's why there are several advancements into a key exchange algorithms and all that. Okay, so that is one portion of the story, which we are saying that for cryptography, you need an identity. Now, why do you need? So that is fine. Cryptography and identity is equivalent. PKI also does that in some shape and form, and we might ask a question on that at a later point of time. But why is the cryptographic identity? Okay, come to think about it. Because again, the trust and the probability.
Correct.
Okay, here is the sentence, and I think it is a very important sentence even for the audience to understand, right? In the digital world, right, trust can be instilled by a probability, right? Unless you are able to prove something, you cannot trust it on the internet because you cannot see eye to eye, just like we are seeing right now. Okay.
Right.
The second thing is, if you want to bring in the probability, you need to have a cryptography. Okay. And for cryptography, you need to have an identity. So for a provable identity model, you need to have a cryptographic backing to an identity, and hence we believe that for any cryptography to work seamlessly, you need to have a provable identity model or cryptographic identity model. Okay. So that is where basically we are.
Okay. So I mean, what we can say, the security and is not without cryptography.
That is.
I mean, we have to. Yeah, and now we are talking about identity, and we have to even secure it. So without cryptography, we cannot achieve this. So it can be an key element, and you can say that of digital world.
Absolutely.
So can you elaborate on what identity model you are proposing? So
sure. I would love to. Okay. So now, before jumping onto the identity model, let's think about it. Okay, all of us, I think, in the audience as well. So if I ask this question, and we have asked this question in the poll saying, what is your identity, right? And if I ask that question right now, and I'll just take a pause of just 2 seconds or 3 seconds, think about it. Who are you into a digital world? Okay, there are many answers which are coming to your head right now. You will say, okay, I am Aadhaar. I am probably my Gmail ID. I am probably my Facebook ID. I am Twitter. For a bank, I am a user ID or a customer ID. For my employer, I am an employer ID and all that. Are you that? Okay, if you say that you are actually Aadhaar, it is actually a fractured representation of who you are into a physical world.
Right.
So I ask the question, same question again to you, saying, who are you, Shravani, into a physical world? Okay, again take a pause and think about it. I think that again a series of answers, because this is a very confusing question, right? And philosophical question in that sense. So who you are into a physical world actually is defined by actually a set of attributes, right? Right from your birth to where you are right now, what you have done is you have accumulated a set of attributes like your birth certificate, right? After that, probably an Aadhaar with the advent of Aadhaar. There's probably a password, driving license, PAN, and a number of things that we have acquired so far, right? So in the physical world, when I ask this question, those series of answers come. That means you are actually an accumulation of those identity attributes accumulated together, right? That nobody can deny. Okay. So in the physical world, you have that probability because you are carrying a physical evidence of that, right?
Correct.
Okay. So that is one part. Not only that, in the physical world, you are also a sum total of experiences that you have collected so far, right?
Correct.
This thing, the interaction that we are doing right now, even the audience, right? Their identity is changing. It is dynamic. Okay.
Correct.
So in the physical world, we are having all of this, the parameters of an ideal identity. Okay. In the physical world, our identity is unique. Nilesh is unique, Shravani is unique, Shrirang is unique, the audience, each person is unique in that sense, right? It is very difficult to represent them in any shape and form, because then I'll have to actually replicate all those experience cases and the attributes for those in order to replicate you or Nilesh, right? I am able to present myself to anybody in the physical life, and so my identity becomes interoperable, right?
Correct.
So those are all the parameters. Now let's twist the story and say, can we replicate this into a digital world? Okay. Now that is possible using the cryptographic identity technique. Okay, and I'm going to
Okay.
explain you how to do that. How do you replicate that? Okay, so in the ideal definition of an identity, and people can add to that actually. This is not a very limited list. The physical, when you do a comparison between the physical and digital identity, there are more parameters which will come, which we will be able to satisfy. Okay,
Correct.
so in the digital world, the ideal definition of an identity is it should be true representative of who you are into a physical world. A. Okay, it should be tamper proof. Nobody else apart from me should be able to control that my identity, because my identity
Correct.
is my own, right? It should
Correct.
be unique
Correct.
across the universe. It should be dynamic, because your identity is evolving, any ever changing. It should be interoperable. That means the same identity I should be able to present wherever I go, and I should be able to operate with those identities. And last but not the least, with the advent of data privacy laws, okay, India has also launched our laws, but let's say the more sophisticated laws like GDPR, it talks about control as well. Okay, control of their data and the privacy. So that is the definition of an ideal identity model that we are proposing. Okay.
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 So,
So that is
yeah. So, can you? What do you mean by evolving and not static? That's what you were telling again and again. And
sure.
can you
Sure.
explain whether it is distributed or decentralized, or what exactly it is?
I'll come to that. I'll come to that. Now, before jumping into the distributed and decentralized of the model, let me explain you basically what we have done into an IAM identity model. Okay. So in the
Okay, I
IAM
am in.
identity model, okay, it is basically we have designed a cryptographic algorithm by which you can cryptographically chain the identity attributes together to form a dynamic cryptographic identity called as IAM. Okay. So if you look at your screens right now, right, as I told in the physical world, you are actually a sum total of all the identity attributes that you have collected so far. Okay, what we have added to that is basically a verification approach by which anybody or a third party can actually verify the identity attributes linked to your identity, and then come out with a very solid cryptographic identity, which then you can use into a physical world. Okay, what
Okay.
it basically does is it basically makes your identity ever changing, dynamic, because as and when you add an event, as and when you add a cryptographic attribute to that, your identity kind of a changes over the period of time. It makes you unique, because if you map these two identities on, let's say you plot a graph, right, of an identity, and you place two identities on that. Okay, even if they have, there says, very same or similar attributes together, because of the time dimension, the uniqueness actually increases over the period of time. Okay, we
Okay.
and because of the cryptographic nature of an identity, it basically becomes a tamper proof. Okay, so from model perspective, we are able to satisfy all the requisite requirement of the ideal identity model. Okay, which is unique, dynamic, interoperable, tamper proof, most secure, and true representative of who you are. And of course, because the way we are delivering the identity to the end user, it is a user centric design, and that is why how we basically ensure that there is a control and the privacy, because whatever events or the data which is basically orchestrated by the user, okay, those remains in the control of the user, and that is how basically we go towards the control and the privacy. Okay, so that is basically the definition and how we actually deliver the cryptographic identity model inside the digital world. Okay.
Oh, so there is one question actually.
Mhm.
Divyang, can you please differentiate with PKI and RA for digital signature? So can you
Sure.
take this question? Okay,
Yeah,
great.
sure, no
So
problem.
I request
Okay.
audience, please post your questions and make this session interactive. And we would love to answer all your questions. So please, Nilesh, can you
Sure.
answer this question?
So, if you look at the PKI model, PKI is primarily a third-party registered model. Okay, from the perspective of philosophy, right? Your CAs basically they kind of issue you your public ID and the private ID, and based on that, you are identified by your private key. So, what you have at the end of the day is a physical possession of the private key, which defines you. Now, just link it back a little bit. Before issuing of your private key to you, what they have done, they would have done some kind of a KYC, okay, with some kind of a data. Okay, let's say your address proof or identity proof or stuff like that, and based on that, the key pair is generated, which has a limited lifespan, and then based on that you are saying that I am I in the digital world, and then you use this for various cryptographic function, including the e-signature part of it. Okay, and we will shortly come to our e-signature as well. Okay, our model, what we do is, although it is based on the bilinear pairing based cryptography and the third party trusted model from the implementation perspective, however, there are two key differentiation. The keys that are generated using basically in our model, okay, always remains in the control of the user. The key generation can only done by the user, not the third party trust, nor any trusted third party. Third party is just the orchestrator of that. A. B. In the PKI, your private key primarily remains static, right? Once, let's say after 1 year or 2 years, once it becomes invalid, then you can actually go and procure another digital certificate. 3, because of the static nature, there is again an increase in the vulnerability, and again from the implementation perspective, there are a lot of headaches of the PKI which are completely replaced in our model. Last but not least, from the dynamism perspective, our identity model is always evolving. As and when you add an attributes to your identity, okay, that attributes basically changes your identity. Okay, and based on that, the keys also becomes dynamic. So the keys are never static in our model. Okay. So that is how it is basically a differentiated aspect, and from the PKI. More than that, Shrirang is going to also talk about a multi-party key signature. Okay. Multi-party signature using a PKI is very cumbersome. Okay, although I don't think anybody uses that. Okay, extremely troublesome to implement and all that, right? However, in our model, by definition, it is a multi-party signature. Okay, because we are talking about from the protocol perspective, there are the multiple parties are involved, and even in the real life, when you do a signature is not done for any one guy, right? It is always you are doing a signature on a transaction where multiple parties are involved. Signature is done on the document where a document is actually shared with multiple parties. That means the consumer identity as well as the provider identity both has to be there from the philosophy perspective. Okay, so sorry for the long answer, but I think we primarily differentiate from the PKI and have a numerous advantage as compared to PKI in our model.
Okay, so there are a couple of questions, but I'll take one or two.
Sure.
There is one question by Professor Sule. What is the mathematical logical formula of making I am from the attributes? What governs its security? Essentially, what is the one-way function which makes I am?
Okay. Okay. So questions from the professors are always tricky, right? And appreciate those questions, okay? Because
and
that kind of
cryptographer and cryptanalyst, so you can expect.
That is good. Okay. So from the cryptographic model perspective, what we have done is we have implemented hash functions combined with elliptic curve bilinear pairing based cryptography, combine that with Shamir secret key, A for doing the authentication and e-signature, and the linking of an attribute. For the linking of an attribute, there is a phenomenon called as in the physics world, there is a phenomenon called as a Markov chain. Okay, the equivalence is implemented into a cryptographic world by us, which is called as a cryptographic Markov chain. Okay, Markov, I think people will understand, professors will definitely understand the Markov. Markov principle basically says that any future occurrence that is happening, it is dependent on the present state and the event that is going to happen. Okay, so from the philosophy perspective, whenever you add an attribute to an identity, the previous identity plus the attributes come basically leads us to new identity model. Okay. So that is right. From the security perspective, I would definitely like to say that we are quantum proof and we can prove that.
Okay. So there is one more question by Professor Sule. How are private and public keys generated from IAM?
Okay. Okay. So again, I will give a kind of a stock answer to that. Okay, because although we have filed one patent so far, okay, which is basically for generating a cryptographic identity, several other patents, including e-signature, IMCI2 protocol, which is combined, which we discussed briefly. Okay, all those protocols are in the phase of patenting. Okay, so the stock answer is we do ECC based bilinear pairing based cryptography, combine that with Shamir secret key and a certain hash function. I won't be able to divulge much on that as on day today right now, but shortly be sure that this knowledge will be a public once we file our patent. More than
Yes,
that,
yes, we can understand that.
from the credibility building perspective, I know it is who are you to say all of this. The cryptographic algorithm has been evaluated by RC Bose Institute of Cryptography, okay, before
Oh,
our
great.
implementation into defense.
So there is one more question, Sudeep.
Sure.
In this IAM model, who controls which events are included, and could some of these be mandated?
I would say a very thoughtful question. Okay, very beautiful question. Okay, so from the
I
data
mean, we are getting
perspective,
a lot of questions, Nilesh. So, I think
Understood.
people want to know.
no problem. I think
Yeah, please.
I love the audience because there are very intelligent questions. Okay, so who
Yes, yes,
controls
yes.
which event becomes the part of the attribute chain? Okay, that is again a
Right.
very intelligent question. So as on date today, from the philosophy, I'll again roll back to the philosophy. The identity owner should be in the control of an identity. Everybody will agree with that, right? Who are you to give me an identity? That's why the self-sovereign identities have came into the picture. That means whatever events are getting added to an identity should be in the control or in the possession of an identity. Now, having said that, there are centralized implementation of our platform in certain institutions already. Okay, where people say that when there are certain events which are basically happening with an identity, based on our policy, we are basically going to link only certain events. Okay, so from the enterprise perspective, enterprise do control linking of the events with an identity. From the mandate perspective, whenever an attribute is added, because attributes are like your identifiers which goes in defining it, right? Those attributes are always controlled by the identity. So two separate things. Events, enterprise can control. Attributes, identity can control. Does that answer?
So if I can just add one more thing quickly to that. I mean,
Sure.
we've seen this challenge about the mandates that is given, right? Every time there is a mandate, there is a somebody goes to the court and we have a problem. So, and then within, let's say, think about the national infrastructure. We've got a zeroth identity called Aadhaar. We've got a zeroth identity called PAN. We've got the zeroth identity called election identity card, passport. There are so many identities that we have, which all of them can stand the scrutiny of the zeroth identity, just like the NIST will define that, for example, or any of the identity standards define that. It's a basic, it's identity that is given to you after a lot of verification, for example. So the mandate is one part. At the same time, this platform gives you the flexibility of choosing from any of these 3-4 to make sure that I have a cryptographic identity that I'm using in the digital world, which is based upon some of these mandatory IDs that I have.
Okay. So I'll take one or two questions and then we will move on to our topic. So one question by Neeraj is asymmetric encryption is taking much resources at CPU and RAM? How about salt and key? So can you take this question?
So from the performance perspective, right, we already have done the benchmarking, okay, based on the ECC or whatever algorithms that we have done so far, okay, and we are also talking about IoT world as well, okay. So I won't be very specific onto the benchmarking and what algorithms which are used, but if we are able to run those algorithms in the IoT environment as well for doling out the identity and doing the encryption and doing the secure communication, I don't think we are consuming much of the CPU resources on top of that.
Oh, great. Yeah. So let's move on to some of my questions. So can you tell us about privacy by design? So we were discussing about it, right?
Sure. I think this is one of the very important questions, okay? And when you are actually talking about building an ecosystem, privacy actually remains actually a very huge problem, right? So these are 7 foundational principles, as they call it, from the privacy perspective, which talks about end-to-end security of the entire data of an identity. Okay, it should be embedded by design. It should be user-centric. Okay, it should not be it should be positive sum game rather than a zero sum game, saying either I will do complete privacy, I will not do a zero privacy. So from our perspective, what we thought is, if you keep an identity into a center, right? All of these 7 principles can be met. Okay, so
Okay.
identity and center, and then you have the cryptographic services around that. Okay, and the by using the cryptographic services, you can do a data control. Okay, so that means the
Okay.
identity will always remain in control of what data is being used, where, in what context, and whether during the life cycle of that data I have the possession of that data. Okay, or I can control the data on top of that.
Correct.
Okay, so what we have done is we actually have done a designed something called as a PI control platform as well on top of that. Okay, around an identity for orchestrating, because identity itself is not enough. You should be able to orchestrate various digital services to be used by an identity. So we have designed a PI control platform, a cryptographic platform by which you can orchestrate various services around that, so that you can do a data control, so you can do an authentication, encryption, okay, e-signing, and of course the data integrity and immutability. Okay,
Correct.
so that is why I think from the future perspective, we believe that our technology that we are talking about, the combination of an IAM and a PI control platform, is in that way foolproof in terms of compliance with the laws, as well as ensuring the security and ensuring the privacy of the end.
Oh, great. But how will this help the enterprise and government entities? I mean,
Right,
this
right.
is
So
very important, right?
absolutely correct, absolutely correct. And I will actually circle back again to the same argument, right, about the provability is a function of a cryptography. Cryptography without a
Right.
strong identity actually has no meaning, right? So if you
Correct.
want to basically have deliver a cryptographic services, okay, to the government, so everybody actually needs to deliver a certain set of digital services. And come to think about it, the digital services are in need of a certain cryptographic functions. Okay, like authentication, identity, encryption, data integrity, immutability, non-repudiation, and all that, right? And there is no limit to what we can do, by the way. Once you have this platform at your disposal, you can actually build your digital services on top of that to actually employ all of this function based on an identity. So whether it is an internet banking that we are talking about for the bank, okay, whether it is an internal digital service that we are talking about, okay, for the enterprises where they need to deliver the services at home securely, okay, which talks about tunneling, okay, end-to-end encrypted channel, for which now we are using a VPN, which is again a broken piece right now. We can argue about that a little bit, right? So you need to do an authentication and all the cryptographic functions together for delivery of any digital services. So whether we talk about defense, a government, or an enterprise, or a bank, any kind of an enterprise are in need of all these cryptographic functions at their disposal, right? And we provide that out of the box, okay, all in one go,
Okay.
from the security perspective.
So I'll take a couple of questions.
Sure.
So Shailendra asked, where are these identities stored?
Okay, wonderful question, actually, right? So so we support two models. Okay, I will circle back to the slide that I have shown right earlier. Okay, let me see if I can bring that up quickly.
Sure.
Right. So these are the models by which you can actually deliver the identity, and we basically support both the centralized as well as a distributed model of identity delivery. Okay, and both
Great.
are pretty useful. If an enterprise wants to deliver their ecosystem in the closed manner, okay, like an open banking or a digital banking and stuff like that, we support the centralized model of delivery of an identity. Okay, by which you can have your own identity, let's say a store where all these identity are stored. The second way is you can actually create a distributed ecosystem where this identity can actually can be delivered in the distributed manner as well on top of the distributed ledger, right? Where probably you can actually democratize the environment, saying, okay, we are actually placing the real control in the hand of an identity. Okay, so based on what kind of implementation is there, so probably for the governments and defense forces, distributed model may serve well. For the enterprises, the centralized model will serve well. And because of the cryptography that we use, we can prove that in both of the models, the sanctity of an identity can be maintained. Okay, so from the storage perspective, both the models are all supported in that sense.
Great, great. Great. So there is one more question. I mean, there are a lot of questions. I'm so sorry for this because
Sure.
people are really
Yeah, sure,
interested
no
in this topic,
problem.
I sense.
Appreciate that.
So
Appreciate that.
yeah, even I am like, yeah, great response, audience. I mean,
Yeah.
so there is question by Abhay. What are the minimum number of identity parameters which can ensure the uniqueness and dynamism in the IAM identity?
Okay. Uh, so there is no such as minimum number of attributes that you can add. Okay. You can actually start from your zeroth identity as an Aadhaar, right?
Mm-hmm.
So Aadhaar, right now, Aadhaar in that sense, it is actually your zeroth identity in that sense, right? From the definition perspective. However, if you want to
Mm-hmm.
really proliferate into the ecosystem, you will need to basically build in the ideal identity parameters as well, right? Dynamism and all that. So as and
Mm-hmm.
when you keep on adding the attributes, okay, so you let's say you link your other PAN card with that, you link your bank ID with that, right? You link another your driving license with that. So it can go on till till actually an infinity. Okay, so there is no
Mm-hmm.
minimum. Although from the
Minimum
ecosystem
is
perspective,
one, right?
absolutely. So, but from the ecosystem perspective, there was, I will circle back to one more question that was there saying, what is the mandatory thing? Okay, just there is nothing mandatory. But the organizations who are actually choosing to rely onto an identity, they would say that unless
Mm-hmm.
boss, this set of attributes are there, I'm not going to basically rely on that. Okay, and those
Right.
policies can be defined by the individual enterprises themselves, and then based on that, the identity consumption can happen. Okay, so this can actually
Okay.
improve the whole ecosystem, and I would say that even the I think Aadhaar is doing the phenomenal job, but link that with the cryptographic identity model that we have, and you will have a very unique model where unique user centric model where all the services can be delivered in the very secure fashion.
Right, correct. Great. So there is one more question by Shubhendu. My question to Nilesh sir is
Sure.
how to take care of spoofing attack even if we are using cryptographical secure identity model, since if it is stolen too, then anyone can impersonate us.
That's a very interesting question, actually. Okay, how do you stop spoofing? And what is the most easiest way to spoof anybody right now? Is basically by doing a very simple phishing attack, right? Now, what do you do with the phishing attack? When the phishing attack happens, you receive an SMS or you receive an email
Mhm.
saying, "Boss,
Mhm.
your card is going to expire unless you click on this link. Your card is going to be basically off from tomorrow," right? And then you click on that
Mhm.
link, and after clicking on that link, then you basically submit your information. Once you submit the information, because you are identified on the internet as your identifier, that person becomes you. Unless there is a cryptographic handshake that happens between the two entities, which is the digital service that you are consuming, like your internet banking and you, right? You cannot stop the phishing attack. 90% of the attacks are like that, right? So what we do
Okay.
is, since we deliver the identity to both the digital service as well as an identity, and there is a cryptographic handshake that happens between the digital service and the identity, okay, I think we are pretty much spoofing free, right? In that sense,
Yeah.
right?
So okay, let me take some of my questions.
Sure.
So
Please go ahead.
okay, uh, so pi control, it's a very interesting name. How did you like the name come about, and what does the platform do? I mean, what
Sure.
exactly it is?
Yeah. I definitely like to take that question. So pi, if you look at the symbol pi, and professors will appreciate, pi
Yeah,
is basically your mathematical symbol, right? And if you look at
correct.
pi, it is an infinite series of nested fractions, right? So
Mm-hmm.
one of our partners, Sanjay, is a mathematician as well. So he came out
Okay,
with a
great.
pi. And why control then? Because at the end of the day, you need to control the data. All the security
Mm-hmm.
that we talk about in the world, it is all about controlling the data. Who should see my data? I should maintain the confidentiality of that data. Non-repudiation should exist and all that. And there could be n number of controls that could be there, right?
Right, correct.
Infinite controls is where we want to go. Infinite
Mm-hmm.
controls in the hand of the user or an identity is the basically a holy grail that we are trying to solve. Okay, so that is why the pi control, and how what it does all of this right now, and it will do many more things when we talk about, let's say, the future of the pi control, what how the pi control is going to evolve. Okay, now this is an interesting
Okay.
slide. Okay, Now think about it again. So that I think the tech people will appreciate this slide the most. Okay, who and operations guys as well, the security operations especially. If you want to deliver a digital service or an application over the internet, what all you'll need today? Okay, you will need authentication. You will need an identity. You will need an authentication. If you are a sensitive application, you definitely need a provable consent. Okay, you for the non-repetition purpose, you need an e-signature. Work from home scenario, people, you will need a VPN or let's say a remote access, right? Interoperability remains a challenge, so you have to work it out. And then encryption and the data control as well. What PyControl does, and if you think about it, you can actually place individual technologies inside that, which are, I would say, most of them are non-indigenous. Okay, in the PyControl platform, based on the identity, okay, we are able to deliver all these services in a box. Okay, what it does for you is it basically increases your security, because we do claim that our security is quantum proof. It increases compliance because you just are managing one platform, right? Right now, you are getting a consent, you are getting an e-signature. You don't have to worry about implementing PKI. Work from home can be enabled with a tick, right? Like we can give a remote access without using a VPN, and there are numerous advantages to that. If there is a question saying how are you better than the VPN and all that, I will address that separately. But we are better than the VPN. We are able to give the encryption and the data control as well inside a box, right? What it does for you, you have a simple one platform, just one. Our customers are actually experiencing that right now. Single platform is solving all of these problems in a box. Okay, and we are actually going to add other cryptographic functions as well in the future. Okay, which will basically help the enterprises. So that's what the PyControl platform actually does for you.
Okay, great. So can you tell us about I am electronic signature? So what defines the electronics and digital signature, and how do you make it like IT Act compliant, So what exactly all about?
So maybe I'll quickly try to answer that question.
Oh, great, Shrirang. Please go ahead.
Yes, thank you. So when we talk about the electronic signature, and when you compare that the signature with the physical world, in the physical world signature, I come and sign on the paper. And because I'm signing in front of somebody, or if I'm signing in the absence of somebody, there is a requirement by the law to have a witness. So there is some other guys who also sign, and their identities are attached. And just imagine the physical world the way it happens. And let's say if you want to commit a transaction, and take a simple example of a real estate transaction or any banking transaction, etc. The parties who are transacting are at one place, they are together. Now, transport that scenario to a digital world. Different parties do these transactions at different periods of time, and that is where I think the challenge in the transaction security comes into the picture. And what you see here, what we have invented is the CI3, which is a collective identity. When I use the word CI, actually the IAM technology uses a collective identity signature. And the collective identity can be had between not more than more than 2 or more than 5 or more than n. So it's like CIN. So I can have a multi-party signature that can be implemented using this technology. And the difference with the PKI, in the PKI, as I said, the PKI, the TTP is involved in actually giving you the keys, and the keys remain static for the rest of the time when you replace those keys. I'm just going slightly commercial. Every time to get my keys, I have to actually pay some more money and get a new dongle and blah blah blah. It's also expensive if I have to have dynamic keys that I need to have in this scenario. So the CI3 and the ID Act, if you can see on the next slide, defines very, very clearly the reason and the mechanisms that ensure that the signature is the ID Act compliant. It's a beautiful job done by the by the Indian government. When the ID Act came into the force in the early 90s, early 2000s, it was mandating a specific technology to say this key is compliant, because the data that is used to create the authentication, the signature creation data, is all in the control of the signature creator or identity owner. alterations are easily detectable, etc. So there is very clear criteria defined. The IT Act was modified not to recommend a technology, but to define the criteria which ensures that a signature will be IT Act compliant. And our claim is that IAM CI3 signature is completely IT Act compliant because we tick all the boxes that are there for the reliability of the signature, and we tick all the boxes of the security specifications of the IT Act compliance. Now, it does not only stop here, but it also ensures that the signatures that are applied are dynamic in nature. And so that is the beauty of the platform. Plus, very importantly, we reduce the cost of signature dramatically. Today, if you see a calculation, the average purchase price of a dongle is 1,000 rupees. And most of the citizens end up making 1, 2, or 3 signatures per year, which means, in effect, the digital signature is costing you 100 rupees or 1,000 rupees per signature, depending upon how many signatures you make. Our model goes as a pay by signature, pay per use. So more than 90%, even if I say 10 rupees per signature, it's a dramatic cost saving. And that's why we believe that we are going to democratize the digital signatures. The RBI mandates to have digital signatures. However, a lot of people don't do it. And I think the earlier example I gave, that my dongle is with my CA, he does the signature, the whole purpose of the signature is lost. So because our signature can work on not only on the desktop, but also on the mobile, on the IoT device, on any such kind of an equipment, you will be able to be in control of this signature apparatus, and you will be able to sign the specific documents. And we also say that we can have multiple parties that can sign the document at the same time, which is something that is extremely difficult to be done in using by using the existing technologies that are out there in the world today. The way it works is that there is a paper on which one person signs, then makes a copy, goes to the other person, then makes a copy, goes to the third person. And internet is the world's largest copying machine. Anything that touches the internet is copied and hacked. So just imagine this paper. I mean, just we've taken this example of a multi-party signature, this very proud moment for India in 1983 when we won the World Cup. Just like it's a proud moment for us, because we are the first Indian company to have this kind of a groundbreaking innovation of having multi-party digital signatures, where unless the 3, 4, 5, 6 parties come together, the signatures cannot be created at all. And that, I think, is the fundamental advantage of the IT Act compliant multi-party signatures that we have invented.
So I'll take 1 or 2 questions before moving on to my questions. How is quantum proof while using ECC? That's what Vipul Kumar is trying to ask.
Yeah, sure. Should I take that, Shrirang?
Yeah, so I think this is, Nilesh, you always have said this, right? It's not only ECC. I think it's a combination of multiple things. And
correct.
If you look at the words that Nilesh had used, there is ECC, there is bilinear pairings, there is hash, and there is Shamir secret. So the important part is Shamir secret, which is based on the information theory. So when I combine these things together, anything that is mathematical is probably not quantum proof, because I can always put infinite resource against it, and I can break it. And something that is based upon information theory can be quantum proof, because stuff could be missing. And I think for the knowledgeable, this hint is enough, because there's lots of other stuff that we talk, that's patent, we filed some patents for this technology, but that's why our claim of quantum proof is so strong.
So I'll just add to that.
So sure, Nilesh.
So typically, if you look at from the theory perspective, because quantum computers are not there, right? So from the theory perspective, anything that is dependent on the hardness of a mathematical hardness of a problem, traditionally people have been using for cryptography the mathematical hardness of a, right, like prime factorization or a discrete logarithmic problem. And then using a Shor's algorithm, you can say that yes, these algorithms can be breakable using certain qubits based on what algorithms that you have used. There is another thought process and which is provable as well, right? So if you use a information theoretic model, right? Information theoretic model actually depends on the missing information and not a mathematical computation. So once there is a missing information, you cannot theoretically compute that. Okay, and that is why we say that our algorithms are quantum proof, because they depend on to the information theoretic model as well.
Okay, great. So, and there is a magic in the mathematics that, when you play around, some properties changes. So you cannot say that always, there are rules. We can even prove 1 is equal to 2. So,
Absolutely correct.
so we can play around with the mathematical magics, and something unbreakable can come up. But yeah, we cannot say that it is unbreakable, because it's like the hackers and the cryptographers is like a cat and mouse. They're chasing each other, and somebody is trying to make a great system, and the hackers trying, or the crypto analyst trying to break it. So yeah, it's a endless game. So yeah, I hope people got the answer, and even Kanak was asking the same question, so I'll not repeat that question, but I think they got the answer for, and it's great that you explained it very well. So okay, so can we take a couple of questions? Oh, how complicated is it to implement the product?
I am from the implementation perspective, I think it is extremely simple to implement. Okay, we support both on-premise, in cloud, or hybrid implementation of a product as well. Okay, which can basically give all of these cryptographic functions out of the box. The POCs that we have been conducting so far, okay, we have a record of conducting the POCs within 2 days as well. Okay, so there are a set of REST APIs extremely easy to consume, which are available along with the comprehensive developer documentation, the API documentation as well. Okay, so from, if let's say, based on what kind of a use case that you are implementing, the time horizon may vary between, let's say, 1 to 3 days if you are basically doing the POC.
Okay, great. Thank you so much.
Yeah.
So I'll take my questions.
Sure, absolutely.
Can you tell something about multi-party digital signature? That's what you were talking about, and it's very interesting to know what exactly do you mean by about like multi-party digital signature.
Yeah, so I think for the multi-party, I think, as I said, the collective identity, I think that's the fundamental technology that we have invented. And the collective identity means that the key generation happens only when all the participating parties are having an electronic or having a provable consent of participation. It's like an exclusive invite-only club, if I have to start, for example. And then how could I use this? Like, for example, there is a lot of board meetings and board minutes and all that kind of stuff. It's like an exclusive club of 5, 6, 10 board members. There is, I mean, as you see on the screen, there's an exclusive club of the teams that are out there. So the key generation is dependent upon the collective identity of all the people who have come together. If you go back and think about what Nilesh was talking about, my identity is evolving over a period of time, so that the identity of this group also evolves over a period of time, which becomes a collective identity for the entire group. And that is a very, very powerful concept, which allows us to use this multi-party signatures to control the group of IoT devices, automotives. Could be various applications of this that are possible with this invention of a multi-party collective identities or collective digital signature. Does that answer the question?
Yeah. Great. So I'll take a couple of your questions. There are a lot of questions, I must say that.
So we can stay as long as we want.
For encryption, is IM efficient compared to symmetric encryption algorithm like AES, etc.? So can we compare it with the symmetric?
Okay, so from the encryption algorithm, so to say, there is no innovation into encryption algorithm, nor I would say that one should do an innovation unless the algorithms are peer reviewed. Okay, our job is to basically do the key exchange and the key delivery, and then for certain cases like defense, they can actually use their custom encryption algorithms as well. Okay, using our key generation technique. Okay, so from the encryption algorithm perspective, right now people have been using AES 256 for basically doing the encryption and then subsequently whatever confidentiality that they have to maintain.
Okay, so there is one more question.
The key is the key, right? I mean, that's the really the cryptic joke that is out there, right? And I think what we're doing is this key generation, which is something that makes it cool.
Right. Okay, so Abhay wants to ask, today we try to ensure reducing frauds and identity theft by multi-factor and multi-device authentication. Does your platform provide this elegantly?
Yes. So as I told earlier, basically the platform is able to basically deliver all of this out of the box. Okay, which is, I will just bring out some other slide. Okay. So this is what it is able to deliver. Okay, we can actually go towards a passwordless authentication with a very high level of security. That means you are actually matching the convenience with the security. You can deliver for the regulation perspective. If somebody wants a multi-factor authentication, we can deliver a multi-factor authentication as well, including the on-device biometric, including the device signature, as well as what you know as a factor. It could be dependent on what kind of a PIN or a password that you want to have. Okay, we can go towards any attribute login as well. Okay, so there could be an exotic use cases like I want to log into my bank using my Facebook ID. Can I do that? Okay, although some people would say that yes, that technology exists, but do banks are using that? No, because again the trust is important, right? Because Facebook ID is controlled by somebody else. We are saying that your Facebook ID can be cryptographically linked into your identity and you don't have to ask Facebook about it, because Facebook ID is my own, right? I'm owning that. So any attribute login also we are able to deliver. Okay, so from the regulation perspective, I think pretty much all the regulatory needs we actually support out of the box, which to do with multi-factor authentication, e-signature, secure messaging, provable consent is the one thing nobody has asked any question so far. Okay, so what is mean by a provable consent? And it's a very funny thing about it, right? So consent seeker is storing the consent of the consent giver today's day. You can deviate from that scenario and you can say that I'm giving a provable consent. We can do a signature on transaction, we can do a signature on documents, and last but not least, we can also enable a secure remote access. Now, secure remote access is not only in the context of the employees who are actually wanting to get access into the corporate network. Nowadays, because of the multi-cloud scenario, you can think about it. In the multi-cloud scenario, there are services to services talk that are happening within the cloud, right? If there is service to service talk that is going to happen, and if you are opening both of the services to the internet, your attack surface increases. What we can do with the tunneling technology, only after the proper authentication of both of these services, they can actually talk to each other. Okay, so you can actually go, you can actually implement this kind of a use cases as well, especially in the multi-cloud environment using the tunneling and identity technology that we have. Okay.
Okay.
There is also a talk. I'm sorry, I'm just giving a long answer because I know that will go there from the zero trust. So there is a nowadays there is a talk about zero trust security as well, right? Everybody who wants to come inside my network, whether it is an employee, partner, or a customer, should authenticate himself. I should do a policy management on top of that, and only then the access should be granted. Now think about this tunneling technology that is available. Only when after the authentication you are actually establishing a network. Okay, so you can actually enable a zero trust environment as well, right? Using this.
Correct.
And then platform basically supports the APIs and functions to implement that, which will help the organization to do a left shift towards the development cycle and secure their assets using all those cryptographic functions.
Great. So, I mean, there are a lot of questions. Some they're asking, can you quickly demonstrate the technology in the action? I mean, it's like.
I think so. We would love to do that. Okay. Our numbers, I don't know how they are published and all that, but do feel free to get in touch with us. We are all available on LinkedIn as well, LinkedIn profiles and all that.
So, Ajit,
we'd love to
hope
answer
you
that.
got that.
Yes, and we love to demonstrate, and we love POCs as well. Yes.
Okay,
so as on date today, right now, I don't have a setup. Otherwise, I would have loved to demonstrate that.
Okay, so Prasanna wants to ask, is Pi control a protocol or a platform?
Wonderful question. So yeah, so IAM is a technology. Okay, IAM is an identity technology. From the protocol perspective, I think Shrirang talked about it, which is called as an IAM CI3 protocol. Okay, CI3 stands for collective identity. So that is the protocol that we are used. PyControl is a platform which is available for the developers to develop the secure applications and consume the cryptographic services. Okay, so this is a ready-made platform which is available to you, which will provide to you out-of-the-box functionality that I have listed onto the screen right now.
Okay, so there is one more question by Abhay. At what OSI layers does the PyControl operate?
Okay. So good, I think we are getting deeper there. Okay, so we do operate at the application level itself. Okay, now the reason to do that is from you can actually go to the cryptography can be implemented at the network level as well. From the protocol perspective, although we have the capability to implement at a network level and then form, let's say, a secure data objects which can flow back and forth. But from the ease of use perspective, we thought that since the world is actually moving up, right, inside the containers, so nobody actually looks at or take care of the containers which are out there or the infrastructure. That is why we have implemented this technology at an application layer, so that the application, no matter where they are, how they are delivered, you will be able to use the PyControl platform. Okay, so from the OSI stack perspective, we actually sit in the application layer.
Great. So I would like to know, like, how will Atmanirbhar Bharat and Make in India be impacting your platform? I think that's really important nowadays.
So I think we talked about Atmanirbhar Bharat, Make in India, which is a very, very, very positive step taken by the government. And today, India imports almost everything in cybersecurity. Most of the technologies that are doing, say, passwordless authentication, e-signatures, or secure messaging, or data transaction signing, etc. Any such transactions are completely done through imported and non-indigenous technologies. Our claim is that we've got a platform that helps us to have our own key generation scheme that helps us. I can just think about that the federated identity or distributed identity approach that Nilesh explained just now. All the defense personnel can come together and have a federated distributed identity that is valid and controlled and contributed by all these different departments. Something that is really, really unique for our, and which means that the communication that happens, which is based upon the keys that get generated from that, are extremely secure. So the possibilities of creating, let's say, an indigenous cryptographic mobile communication mechanism, possibility of having our own multi-party signatures, the possibilities are there, and we are really hopeful that I think in the past the issue was that what is your credibility, and there is like a lot of issues, but we've got some lot of good help from professors, say in ISC Kolkata or in IIT Madras or in ISC Bangalore. We've got a lot of motivation and support from this ecosystem to help us build the core technology and the platform around it. So we're really hopeful that India will be able to make a mark in the world of cybersecurity through this technology.
Okay, great. So there is one question I would like to know, like, how is the platform helping current customers? So you have already started using it?
Yes. So this is that. Yeah. So I'll just cover so probably you can cover that. So platform is already in production, and a couple of installations that we done, very sensitive, and I would definitely like to mention the contribution that has done by Yes Bank and especially by the CIO Anup Purohit. Okay, he has been a phenomenal supporter. We actually need more CIOs for the Indian startup ecosystem who are ready to experiment with you. Okay, so in Yes Bank, our journey started with the corporate customers where we secured them the multi-factor authentication, provable consent, and e-signature. Moved on to employees and securing the employees, some of the partners, and now we are moving on to secure the retail customer base as well. Okay, so from the journey perspective, they started using for their internal digital services earlier, moved on to the enterprise services, and then now we are also in talks about actually building a vibrant ecosystem inside the Yes Bank for doing the open banking initiatives and several other initiatives. Okay, There has been a usage in defense as well, where the platform has been implemented in defense. Although we won't be able to disclose the use case under which it is done, but it is already there, deployed, tested, well tested by various government agencies as well. Okay, so very much.
This is where I would like to call. I think it was very good help we got from the defense and. General Nair, Brigadier Manjeet Singh, some of these guys who are really people who are willing to take, share the problems and are able to experiment and try out and work with us. I think that has been really, really useful in implementing this in a defense-like harsh environment where I think one thing is the security, but also the other software requirements are extremely critical and very harsh and very stringent to meet.
Okay, great. So I would like to ask you last question. It's not something which is what you say. It's a little, you will feel, what exactly do you, like, why name FortyTwo? I mean, what is the story behind?
So FortyTwo, I think, is an interesting name. I think this was when we started the company. Some of us are geeks who like to watch sci-fi movies, read sci-fi novels. So there's one of the original sci-fi novels, Hitchhiker's Guide to the Galaxy, in which the number 42 appears. And eventually, I think we came to know it was a joke, but I think that that it is the answer to all the unknown problems of the world. So we wanted to build an answer to the cryptographic problems that exist. I think a more apt explanation about FortyTwo lies in the picture, in the below picture that you see. Jackie Robinson was the first African American athlete to compete in professional sports. He broke that glass ceiling that existed, which talks about that certain types of people cannot do certain things. And if you relate it back to what I said earlier, most of the cryptography, most of the cyber security is not done by indigenous platforms. So we really want to be the ones who are the first ones who break the glass ceiling and have many more and cultivate the startup ecosystem in India for cyber security, just like it flourishes in Israel, where multiple cybersecurity startups are nurtured, supported by the government and by the local community, etc. And I think once we started with these two stories, people told us many other stories, like 1942 Chale Jao, or somebody said 1942 love story. But I think there is one interesting part, which is the asterisk. I mean, asterisk in the ASCII is 42, and asterisk is like star, which means everything. And we want to be the cryptographic platform that is star for everything that is required for securing the digital transformation. I think so. So I think there is a lot of passion behind it to build an indigenous identity-based cryptographic platform that can be the star for cybersecurity, and which will be which will break the glass ceiling.
Great. Thank you so much, Mr. Nilesh and Shrirang, for incredible discussion on digital identity. I'm sure this innovation will be useful to the cyber security community. I hope all the attendees are satisfied with today's discussion. Dear attendees, thank you so much for the splendid interaction. We will come up with more such an inspiring innovation in the next episode. So stay tuned. Until next time, stay safe, stay secure. This is Shravani signing off.
Thank you. Bye-bye.
Shravani. Thank you. Bye-bye. Thank you, audience. Wonderful questions.